fuel cell modeling. And then in the tutorial using MATLAB, we are going to be talking about how we can model fuel cell to doing different analysis. Now, there might be again some repetition, but I will just skip if there is a repetition, because we already talked about some of that electrolyzer fuel cell basics in the previous talk. So, these are the topics we are going to be covering, but as I said that some of them I have already talked about. So, although we talked about like green hydrogen, that using electrolysis process we can actually produce green hydrogen, but if we want to use again electricity from green hydrogen, then the technology that we use, that is actually called like in the fuel cell, and fuel cell converts the chemical energy available in the hydrogen to electrical energy. You know that normally we produce electricity from like sometime electromechanical, converting mechanical energy to electrical energy, for example, things like wind turbine. So, wind turbine we convert energy available in the wind to mechanical, and then from mechanical to electrical. But here like photovoltaic system, so the energy conversion process is like electrochemical, from like chemical to electrical. Now, again you might already know about fuel cell. So, fuel cell have got mainly three major part, that anode, cathode, and then electrolyte. And later we are going to be talking about that whatever type of fuel cell we mention, that's actually depend on what type of electrolyte actually we utilize inside the fuel cell. So, what actually happening here, that in the anode there is the input like hydrogen, we apply oxygen through like that cathode, and what is happening that using that electrochemical process. So, the what hydrogen is coming here, that is actually split into proton, and then we have got free electron, and this proton that we are splitting from that hydrogen, it goes to the cathode through that electrolyter. And what is happening after coming here, that proton and that oxygen and electron, that actually again producing water, but that free electron coming from hydrogen, when it passes through that external electrical circuit, that is actually electrical energy. The process actually quite simple. The way that actually it generate electricity from that input hydrogen and oxygen. Now, we here just talking about the fuel cell, but if you talk about the whole system, it's more than only like the fuel cell, which we are going to be talking about later. So, it does have other parts with the like in the overall system. Now, before going like details about that, again fuel cell also have got different application. We already mentioned like the transport, it could be car, bus, truck, train, ships, aircraft. You might have different stationary application as well, like if you want to have a backup power supply system, it could be for a laboratory, it could be for a small community, it could be houses, it could be hospital, it could be university campus and so on. And there it also sometimes used with combined heat and power plant as well. It can be used for portable power supply for the portable devices, and one of the application they are seriously thinking about the military equipment. for applying like fuel cell application, and also it has a potential for space exploration as well. So there is a one industry space, you might know that Apollo, they are already actually using fuel cell for their space applications. And this is little bit like history. Again, you might know that it started 1960 with that the first generation alkyne fuel cell. Then after that we have like number of research and development to improve their performance, and in 1970, 80, 90 and even after 2000. So there are many things happening to improve their overall power rating, to improve their efficiency, to even improve anode, cathode, and also the electrolyzer, electrolysis process inside the fuel cell as well. Now, in terms of the important features of fuel cell, like if we just compare that whatever energy we are getting from like other chemical sources, for example petrol, natural gas, using combustion, steam turbine, and then generating electricity from that, you are going to get maximum like 30-35 efficiency. But if you just use like the fuel cell, and if you combine that CSP, like the thermal energy that we are getting, if you utilize that energy, then overall efficiency could be around 80%, but only like if you do not use that thermal energy, then it is going to be like a 40 to 60%. But still you see that it is much more efficient than if you just compare like the conventional power generation that is coming from like chemical energy. Other features like as I say like that, there are number of efforts that currently going on just to develop that ion exchange member electrolytes that I mentioned in the previous, with much more efficiency and longer lifetime with minimum cost. So if actually that can happen, then definitely the overall hydrogen price going to be reducing significantly. And these are the some of the like expected lifetime duration for fuel cell that being used like heavy duty vehicles. We are expecting minimum like 8,000 hours, 30,000 for like heavy duty truck, and 80,000 for like that's going to be utilizing for grid application, distributed power system. That's I already mentioned the efficiency, and definitely this is environment friendly as well. There are number of advantages if you compare with even like the combustion process that we mentioned, that you can produce electrical energy, and even if sometime if you compare with its other competitor battery, it also have got some advantages as well. Definitely it can actually have longer operating times compared to battery. It can operate wider temperature ranges. Sometimes battery its lifetime actually reduced significantly. It actually operate in very cold and very hot weather, and also this is efficiency as already mentioned. It's silent and it does not have any the rotating parts. It needs less maintenance. So these are the some of that advantage compared to combustion engine, or even like compared to battery as well. But again, like still there are some challenges as well. So this technology need like a constant fuel supply. It's still quite expensive, and it does produce DC. So as you know that we mostly use AC in our home, so we need like inverter, converter, technology with the fuel cell. If you want to have power supply in the AC load. And also like in terms of transportation application, it is heavily limited by lack of facility for hydrogen storage and distribution, that we already mentioned. There are so many technology now already available in the market as a fuel cell, but as I said that most commonly you will find alkyne. We also have like for phosphoric acid fuel cell, we have molten carbonate fuel cell, polymer fuel cell, and also the solid oxide fuel cell as well. Now if you see here, all of them have like different temperature range, but if you see that PEM, which use like polymetric as like electrolyte, that has very minimum like temperature, it's like around 80 degree centigrade. But the other than that, the other one have got comparatively higher operating temperature. For example, you see that molten, it is comparatively very high temperature. In terms of like efficiency, still this is without using heat, but as I say that if we use heat, then this efficiency gonna be much more like higher. And also like for power plant and vehicle application, we need higher capacity, which is PM electrolyzer has. So other one, the solid oxide, that also like have comparatively a higher capacity as well. But so far this is the one most people are giving more attention for the PEM technology. Now again it will, like I'm gonna don't repeat it, the same principle, but only difference here you can see that it does have anode cathode where we have got hydrogen and oxygen input. Only difference here that we use like potassium hydroxide as electrolyte. And what is happening here in anode, like in anode reaction from hydrogen, by splitting hydrogen we are having that's initially happening from oxygen. So from oxygen and water, and then whatever electron we are getting, using that one we are producing oxide ion, and this oxide ion passes to the anode via this electrolyte, and then at the end at the cathode using using that it actually produce at the anode side using that oxide and using that hydrogen coming as input. Finally we produce free electron, and this free electron again that is actually flowing through external circuit, which is again nothing but the electricity. And overall you will also get water as a byproduct as well. Now again this technology in general, that's like the summary. So again for this one, as we were talking previously, actually it needs actually pure hydrogen as a input. So other things we already have discussed, and it does have got already some application. The space program that I mentioned, Apollo, they actually use this technology for electrical power supply as well as for drinking water for that space shuttle as well. It also have got the military application for having like portable power in very controlled environment, which is carbon free, and it does have application in some other industry as well. Again, I mean, if you want to have very details about comparison like in terms of efficiency and disadvantages is giving here. So, later I mean when you have got time you can also read, but again this is again so like that this is one of the highest electrical efficiency among fuel cell which convert chemical to electric very efficiently. It can actually operate with number of relatively inexpensive catalysts like nickel, silver, metal. So, if you compare with PEM, which I mentioned, which actually need actually very expensive electrolyte, and that use actually platinum. The platinum is a very expensive material. So, as it use like less expensive, it has got lower catalyst cost if you compare with other one, relatively fast startup because temperature is not that high, because when you have got very high temperature you need relatively higher time for starting the whole system. So, in some cases if you need electrical power supply with very short period of time, then those electrolyzer which have got very higher operating temperature, I mean that might not be like a best like electrolyzer for having quick power supply. But one of the problem for this one that this is quite sensitive to have like carbon dioxide, because if you have carbon dioxide either from air that's coming, or if you have got impure hydrogen, that's I mentioned previously, it actually reacts with the alkaline electrolyte to form actually carbonate, and this carbonate actually within that electrolyzer it does block that reaction site, and it's contribute to degrade the performance, and ultimately it actually reduce the lifetime significantly. So, it does need like pure input I mean for this type of technology, and compared to PMC or also it have got lower power density. It also need I mean that carbon dioxide I mentioned, like it needs better management for carbon dioxide management, and also like that other liquid handling process inside the device, that also increases the overall complexity and the auxiliary system requirement. Then again I am just quickly go only again I mean you see that similar process, but the difference again I mean the electrolyte. So, here you see that we using like the phosphoric acid as a electrolyte, that to convert chemical energy from fuel to electrical energy. Again that from same process like from hydrogen you are having proton, electron, and then a proton passes to the cathode through that electrolyte and combine with hydrogen oxygen and produce water, and the free electron is coming from here that produce electricity. So, the process chemical reaction all are same. So, the only difference would be again in terms of efficiency, in terms of tolerance to carbon impurity. I think this one have got better tolerance than the previous one, and combined efficiency also quite better. Messier technology already available, but the temperature is little bit higher than the previous one. So, that is why it had got slow startup time, and also the efficiency comparatively lower than PEMC. Next one, the molten carbonate fuel cell. Again the difference here that it operates very higher temperature, and we use the molten carbonate salt like in the electrolyte, but again I mean the process is quite similar. From like the cathode we have carbonate ion which passes here, and then whatever it's combined with the hydrogen, and then it produces free electron, and that free electron is nothing but the electricity. It also have got many application. Some of the common that it can be used distributed CSP plant, waste to energy or biogas power system, and with CCSP as well, because it does have some carbon as well. Again, with all the same parameter, but it's just some comparison, efficiency, tolerance to carbon and so on. So again, I'll just leave this one. You can read in your free times. So this is the one that I was talking about, proton exchange membrane. And many of you, like if you are working in this sector, you might be working with this technology. So it uses like polymer electrolyzer membrane, like it uses solid polymer membrane as electrolyze, which is again, as I mentioned, it's quite expensive material, and that's the reason it's expensive, but it actually much faster than the PM. So in case of providing that ancillary service, as I mentioned previously, we'll show later, but actually this one provide much better performance than the first generation fuel cell. So again, the process all are same. We have the same input, but only difference the electrolyte. So again, from the hydrogen split, we have got proton and electron. This proton is passing to the anode, producing water, and the free electron is just like the electricity. So it has got comparatively low temperature, 67 to 80 degrees centigrade. It use like it need a pure hydrogen with actually very strict requirement for like the carbon dioxide, and as I said, it also have got many application as well. Again, I'll leave this one to read for your free time in terms of like doing advantage and disadvantage, because this is quite important, because when you're going to select that which technology I'm going to use for a particular application, then if you have knowledge that comparative analysis between them, then you can find out that which one might be best application for particular application that you might be working. So this is also something that's number of research work is like going on. That also use like high temperature, but here they use like ceramic solid oxide here as a electrolyte, but in terms of like principle is quite same like chemical reaction that actually produce hydrogen. Only difference again would be that how it is tolerant to impurity, like is efficiency, again like the cost, and also the the operating temperature as well. And it's given like again all the key features and also different application. So only things, as I said, that you see this has got very higher temperature, but also it can use like different fuel as a input. So it has got quite flexible in the input side as well. Again, I'll not read this one, because it's just like different facts about advantage disadvantages, and it has got very slow start and shutdown time, considering that the temperature range, but it also got good efficiency and fuel flexibility as well, which is quite important when you're gonna think about for different application. Now we just talk about like fuel cell, but what about if you think about the fuel cell, the whole system? So, the whole system actually had got number of subsystem. We already talked about oxygen supply and hydrogen supply in anode and cathode, but that is not only the fuel cell system. You need like the heat management because you see that different one operates in different temperature. So, we need a very good heat management system, and also it involves water. So, we need also water management system, and we also need like power conditioning for its better performance and longer life. And not only that, we also need like different sometime monitoring, sensor and control to improve that overall performance of the fuel cell system. Now, that we just mentioned like fuel oxygen input, but that oxygen is not like that, is just directly putting oxygen. For oxygen input, we use a system like that which has got number of subsystems. So, for example, that we use like air filter to remove any impurity you might have in the input fuel. Then we have also like the compressor, which is powered by like which is motor, like just to pressure and deliver air and a control flow rate to the fuel cell stack. We also have humidifier, which actually you need to maintain hydration and also prevent any performance loss. And then some of them also have like heat exchanger, just to preheat incoming air that's coming from waste heat from the system, like to improve the overall efficiency. We also need like flow control valve sensor, although it is not shown here, but as I said that if you want to remotely monitor control, then we need that different sensor and remote monitoring and also control system for optimal operation of the whole system. And also it does include cathode exhaust system, just to manage removal of excess air, water vapor and also the heat, and it can be integrated with the thermal recovery for water recycling process as well. So, this is the way that we use oxygen input to the overall fuel cell system, and same like that one for the hydrogen supply. We do not directly put hydrogen in the fuel cell. We use a system like that, where you might have hydrogen in the hydrogen tank as a storage. It either liquid or it could be gaseous form. Then we do have regulator, which can be used to reduce or increase the pressure to a might be suitable for your fuel cell application, depending on what type of fuel cell actually you are using, and it can maintain like stable operating pressure. You see like that if you use like high pressure tank, that might be the pressure, liquid that might be in a different form, in different temperature, and also the solid. But anyway use can be using like a system like this as a part of hydrogen supplying to the fuel cell. It also have got some other devices like monitoring, control, and sometimes we also use like that hydrogen recirculation pump. Some of them unused. You might again use like the feedback loop to put it back and use it to improve the overall efficiency. We also have like shut off valves and safety device. For the protection of like for the whole system during like unwanted situation. And then as does involve water and heat, so we need like water and heat management system, either to improve the performance, durability and the safety of the fuel cell system. And once you have that management system, it gonna be like having like the temperature regulation and also the water balance, which might be critical for different types of fuel cell. And one of them, the critical one, that one it does need actually very specified temperature and water balance to operate. And not only this one, the other one also you mentioned, it does need like water and heat management system. So this is like you see that we have got heat exchanger, water tank, water pump. So for all this to operate, actually we need that particular management system. And this one actually showing like the heat, and the previous showing like the water. Now these are the like main component for water and heat management system, and you see like all of them has got particular function. For example, like the coolant pump, temperature sensor, water separator, radiator, coolant loop, dehumidifier, humidifier, all of them have got particular function in the water and particular heat management system. Now later when we are going to talk about more detail about the modeling, in some of the application you see that we model all of them. In some cases, I mean for certain application we neglect some of the modeling, but what I am trying to say that at least you need to have good idea about that total fuel cell system, like what are the different component, what are their function, and then how we can develop that management system for the overall system. Now later I am going to talk about more of the total modeling, but these are the like simple flow rate for the coolant normally used for that water and heat management system. So I am not going to talk about more detail about the mathematics, because I am going to talk about that one later. And this is like more about that water system, water balance, that water in and also the water out for the whole system, and using the balance we can develop that differential algebraic equation if you want to do modeling and simulation for different purposes, that I am going to talk about the next lecture. So this again I mean that that's I mentioned that water balance, it does actually depend on the oxygen flow rate, it does depend on the operating temperature, different pressure, stack outlet pressure, ambient temperature, pressure, relative humidity, all of them going to come into the picture if you want to have very detailed physical model of the whole fuel cell system. And it's not only that, even if you want to integrate with the grid, and if you want to supply power for the particular application, we do need inverter and converter, and we are going to also talk about that DC to DC and DC to AC inverter later, but you know that all of them have got different functionality. It's not only converting from DC to DC, but that's one of the function. It can step up or step down, but also we do apply MPPT, that for like solar system and even for fuel cell. We need that control to make sure that whatever operating condition changes, any condition, we are getting maximum power, and that's control implemented in this DC to DC converter. And then finally inverter, it does invert from DC to AC, but if you want to apply different active reactive power control, that also we are going to be discussing in a coming lecture, that can be done in the inverter. So again I mean it does involve number of devices when we are going to talk about the whole fuel cell system for modeling analysis. I mean in many cases we need to model all of them. In some cases we can use some of them, neglect some of them. So here you see number of them, like inverter, converter we can use, but we're going to also have one session on different buck, boost and other type of inverter for stepping down, stepping up, regulating DC voltage and so on. And all of them have got certain typical use as well. And then for inverter also we have got different types of inverter, considering like the stage you might have single or two stage, depending on grid connection. You can have either like a voltage source or current source. And also in recent year that the multi-level inverter is also getting quite popular. So it could be like a multi-level converter also got different topology, like it could be like neutral point clamp NPC, cascaded Hayes bridge, flying capacitor, and so on. But again this DC inverter, it does convert from regulated DC to AC, but also it has got other function like that. If you want to get connected, then you have to synchronize with the frequency. So it gonna be either 50 hertz or 60 hertz, depending on which country. If it is like Australia, India, I believe 50 hertz, but if you go like Japan, USA, 60 hertz. And also like whatever the voltage level, that has to be synchronized as well. And also it does involve the protection as well, like over voltage in many cases, isolating detection, and so on. So as an inverter, but it's not only inverting from DC to AC, it does involve number of other control and protection, and depending on your research and project, at the end you're gonna be using whatever the model and simulation you need. And the other one also, like as I said, we're going to be talking about grid forming and grid following, and this is mainly based on the grid connection strategy. So if it is grid connected, then we normally use grid following. If it is it can be used in grid connected, but mostly when you have got weak grid or off grid, then normally we use the grid forming inverter, because it has got very good control capability. Even in many cases they have shown that it's almost like a synchronous generator, which that the technology which is providing most of the control function now in the current grid, like voltage, frequency and other control through exciter, and in some cases in other fax devices. But in grid forming, it has got actually capability to provide most of the control function that is being actually supplied by synchronous generator. And again, both of them had got different control. You might already know about some or many of them, but when you have got grid following, it does involve PLL, for the synchronization purpose. But for here we don't need actually PLL, because it actually produce the frequency and angle reference. So it use virtual synchronous droop control PSC to create voltage and frequency. And you see that use cases could be microgrid, off-grid, backup fuel cell. But for this one, either PLL based current control loop, and as I said, the function mainly to inject power into the grid, and also just synchronize with the current grid, and it's mainly used for grid connected system. Sometimes you also have some special configuration, like sometimes it could be bidirectional inverter, and this application also getting quite common, mainly if you use the storage. So you need to charge and the discharge the battery even for fuel cell storage, producing hydrogen, and from hydrogen to again electricity. So, we need actually the bidirectional system, and that also can ensure the regenerative operation as well. And also the other technology, who are working in the power electronics, they are also working on the MMC, modular multi-level converter, because it is quite efficient, and as it is modular, it is scalable as well. And when you have got large scale stationary fuel cell, this might be the better solution for that particular application. So, anyway, I mean, what type of technology we are going to use? Again, I mean, as I say that it depends heavily on the application and I mean their characteristics as well. Now, that is more like the technology, but the fuel cell has got particular characteristics, and one of the characteristics of whoever working in the fuel cell, we heavily utilize the polarization curve. I mean, here you can see this one, and if you want to produce this curve, I mean, you can do this like experiment using electrolyzer, which might have solar module, and then that's like the fuel cell, and then different, because at the end you need to measure voltage and current for the fuel cell. So, using voltage and current, I mean, if we actually draw the characteristic curve, you are going to get the curve like this. So, you see here there are mainly three regions. One is activation polarization region, ohmic polarization region, and then this mass transport polarization region. But when we actually operate that fuel cell, we mostly operate in the ohmic region. So, when we like do model analysis, you make sure that we operate in the ohmic region. So, this three region, I mean definitely there are some like involved with there are some losses. So, the activation losses, I mean just to activate that fuel cell operation, and as it has got resistance, it does involve like some ohmic losses, and it mostly like resistance dominate, not like dominated by induction. So, you get mostly like linear part. Then you could also have other like characteristic in terms like the power density, how much power you are getting per unit area, because we need like higher power density, mostly that will make the overall system compact, and this is one of them actually that have got quite potential to have higher density. Also, we need to check like when the load changes, how the efficiency changes, like how is the efficiency at the low load, how the efficiency at the very high load, and definitely the lifetime and durability, that is also quite like important, and we need to find the characteristics for different fuel cell technology as well. So, I already mentioned, but here if you want to learn more details about those region is given. So, again as I say, like this is the over voltage required to overcome the activation energy of the electrochemical reaction, because to start the chemical reaction we need some voltages, that is like we consider as a losses in the overall system, and the over voltage is like not very high, is 0.1 to 0.2 volt. And then later due to that resistance, we have got that polarization part, and the cell component that contribute to electro resistance are the, we have got electrolyte, we have got the catalyst layer, the gas diffusion layer, bipolar plates, internal like the contacts, and even the terminal which have also connection, all of them actually contribute that internal resistance. And then there are like the mass transport, like water, So, for that also there are some losses which is mainly model here, but in many application we neglect that part as well, because that is not actually quite significant. Fuel cell efficiency, I mean again like all other technology, I mean if you measure output and input, you can find efficiency. Normal range like in 40 to 60%, but if you combine CSP, it's gonna be more than 80%. And some of the factor that affect that efficiency is like different fuel cell technology that can actually alkyne proton exchange member that can affect the efficiency, operating condition, pressures, flow rates that can influence efficiency. The loads, fuel cell may have slightly lower efficiency when you have got lower output. If you operate like rated capacity, you might get higher efficiency, and also the maintenance and internal energy consumption due to parasitic, that also might affect the efficiency as well. So, if we have got like proper maintenance, that might ensure proper operation, and that also can improve efficiency. So, you already know that I am not gonna. So, if you want only individual efficiency, then you can power output, chemical energy input, but if you want to with the heat, then also you need to add heat as a energy output as well. That one showing like efficiency for different fuel cell technology, but if you see that PEM, that quite good, but other also have got efficiency, but in other cases they have got other limitation. So, if you compare with other power plant, then you see that fuel cell have got significant compared to internal combustion IC engine based car, coal power plant, gas turbine combined cycle. So, you see that in terms of efficiency, fuel with CSP that has got significant like higher efficiency that one. Yeah, so these are the some of the required hour that's need for different application if you use. So, that's I already mentioned in the previous slide. So, again just to conclude, the future definitely is like a green hydrogen and fuel cell, that's a core technology if you want to generate power from hydrogen. We need like further research and development work to improve the efficiency. Some of the different limitation I mentioned for different fuel cell technology. So, that also we need maybe further work to address those, and yeah, definitely is going to be playing a significant role in decarbonizing the transportation sector, industry, and power generation. So, I think that's all like about your basic understanding about different fuel cell technology, but how we can model it and also analyze with the grid integration. I'm going to be talking in the next lecture. Thanks for your attention.
So, question for the, because it's possible to provide the dynamic response, that is the transient response.
Okay, yeah, that's a still it's not fuel cell, but there are also some generator already available that can use hydrogen and actually produce electricity. That if we use hydrogen, that definitely that can provide inertia and other like ancillary service to the grid. But even like the inverter technology that I mentioned, that if we use that grid forming technology either for fuel cell or even for electrolyzer, because electrolyzer is just a load, right? But even if you control that one as a load, you can actually solve number of problem in the grid. but this is more like a generator. But even with that, if you use like grid farming technology, then later we are going to show that even some of the case study and example that in Australia I know that there is already number of like real project connecting with the grid to see that how grid farming technology from battery, and some of them they are planning from hydrogen as well to solve that problem. So to answer your question, yes, that's possible, but again the grid farming is relatively new technology, right? So there are number of research work is going on to improve the control and also like the overall energy management system that might be able to provide better ancillary service to the grid. But having said that, I mean, when most of the thing is still like research and development, right? But to employ like in the massive scale, definitely we need more pilot project to ensure that it actually provide the whatever service it's supposed to do that, because the grid is like a very critical sector. We can't just do experiment by connecting any technology which are not matured and practically ensure that it actually can provide the service it's supposed to do. So definitely we need more research, pilot project and demonstration, but actually it's possible.
Battery for the in between the fuel cell and the load, that's a motor.
Well, battery is not the component for because it producing electrical energy from hydrogen, right, using fuel cell. So yeah, battery is definitely not important
not
for for if you want to store it like even like a separate device, but I don't think you need it, because if you have got stored hydrogen, right,
okay,
you can generate from that one. But if you see that I have got certain amount of energy hydrogen like in the car, and we are going very long distance, and I don't have any fuel cell station that I can again fill up. But again, if you want to do that, the cost gonna be very high.
Yeah, that is okay. But what I am saying is the fuel cell, because we stand that amount of power.
Yes, that's definitely possible.
Possible. Okay.
Yeah.
And sir, what about these metal hydrides and the fuel cell?
So metal hydride, in Australia, we already have one. Just you can put it like in any, but they're quite actually small. You can put it like in your garage and things like that. But there is still problem that the efficiency is actually quite very low. So they actually need to improve that efficiency. Also, in terms of cost, that when you buy electricity from your grid like an operator, or you are getting electricity from your solar, right? So if you want to get power from fuel cell, the cost has to be comparable. Otherwise, why are you going to pay more money just to buying that technology and putting in your home, right? While you have got option to get electrical energy from other sources. So to answer your question, yes, the technology is available, but in terms of cost, it's not feasible.
Yeah, the compressed this one hydrogen, we can the safe operation will be possible, no?
Yeah, that's possible, but in terms of cost, I'm saying like that in terms of cost, still it's not feasible if you compare with other option.
Okay, thank you, sir.
For the efficiency optimizations, so to optimize the efficiency, which parameters we have to consider for that?
So the MPPT again, system. During the different part of the day, you have got different intensity for the input light, right? So when that condition changes, so you have got voltage and current, right? So if you multiply voltage and current, you're going to get the power.
Yes.
But that let's say, I mean, you are operating at a particular point at certain condition, but when the condition changes, if you continue to operate at that particular point, you might not be getting maximum output power. So, that MPPT what it does, that considering all the factors, it continuously changes like the operation of that inverter, I mean on the converter, to ensure that for any condition you are getting, it is not maximum efficiency, it is maximum output power.
So sir, the thing is that to extract the maximum power from the fuel cell, we need to focus on the control strategy of the converter side, like a
That's
duty
right.
cycle or everything, similar like this.
Yes,
Okay, thank you.
but we're going to be, you know, again talking about the control and DC-DC inverter. That time maybe, you know, you will be like more clear how you're going to do it. But again you are right, mostly is the control part, nothing about the power circuit.
Power side.
Yeah.
Okay, thank you, sir.
Yeah.